This week in geometry, we are looking at triangle centers, the incenter and the circumcenter and the centroid and the orthocenter. And something that today we tried to do in class was a lab with Geometry Sketchpad, which is an awesome geometry software. And I went to the lab and we went in there, and lo and behold, the software was not on any of the computers. And I have since found out that at the last reimage, it's not on a single computer lab in the entire school, which is something that we've used a lot in the past, so I was kind of surprised by that. But as a result, what I want to do is show you what you could do with that, just with me doing it. And I really think that you'll still get something out of this. So if you will bear with me, I know you can't do it along with me, but I'm going to go through the lab that you as a student would be going through if I had this on any computers. And I mean, I even considered trying to log in as me on 30 computers in the computer lab, but logging in as me still did not work. So apparently the only place I know that it is for sure is on my laptop, and here we are. So the first thing we're going to do is we're going to construct the circumcenter. And I used what's called the segment tool, it's right here, to make a triangle. I already had it set up to show my labels, which is right here. If it's not set up that way, you can do that, but automatically when I make a point, it's going to show the point, in other words. And I'm going to make the circumcenter of this triangle. Now, first thing I have to do is figure out what makes a circumcenter. Well, that would be the perpendicular bisectors. So to make a perpendicular bisector, I have to have two situations. It's two words, perpendicular bisector. So I have to bisect the segment and I have to be perpendicular to it. So first of all, bisecting the segment really means finding the midpoint. So there's the midpoint of my segment. The original lab actually asked you to go ahead and highlight all sides. Actually, that would have been good. Let me just show you something. All three sides and then find the midpoints. If I try to find the midpoint right now, do you notice this is not darker? It won't do anything. Here's why. Geometry Sketchpad is really picky about what has to be selected, meaning with the arrow, what has to be highlighted before you can click on something. And that's because it needs certain information in order to be able to do it. Kind of like if I say add two numbers, you need to know which two numbers. So if I say find the midpoint, they need to know of what segments. Well, this is not a segment, so I have something extra highlighted. If I unhighlight that or unselect that, now it will give me the option of finding the midpoints of those two segments. Okay, so perpendicular bisector, we've got the bisect part because we know where the midpoint is. The perpendicular part means I need to be perpendicular to the segment that's being bisected. Okay, so what the computer needs to know, what the program needs to know, is it needs to know what do I need to be perpendicular to and where do you want me. So I'm going to say be perpendicular to this segment and go through this point. And then when I go to construct, it'll ask me, do you want a perpendicular line? I sure do. Now the beauty of doing it through construct and not just drawing it is that it has made it so that it is definitely going to be perpendicular and definitely going to bisect, which means if I pick one of the vertices of my triangle and I start moving things around, notice that that segment stays perpendicular and it stays right in the middle. So it's most definitely a perpendicular bisector no matter what I do to my triangle. Okay, so now I'm going to go, and did you notice what I just did there? I went over here and I clicked. That's because I don't want the wrong things highlighted. I want to always make sure I'm in control of what is highlighted and what's not, so that when I ask the program to do something, it knows it does what I want it to, because I've given it the information it needs. Okay, so other perpendicular bisectors. I'll do this one and this one. And look, they are concurrent. They all meet in the same point. And let me find that point. That point intersection is point G. We're going to call it point G rather. And I'm going to move. If you want to do something with the label, you can use your select your arrow tool and move it to the label until it becomes a little hand with an A on it. And then you can play with the label, maybe change it to another letter if you want to. Okay, I'm going to take all three perpendicular bisectors and I'm going to make them dotted, display, line style, dashed. I'd like to make it a little thinner. Those are my perpendicular bisectors. So they meet at the circumcenter. And what we were trying to explore is, where is the circumcenter? Well, this particular triangle, ABC, that I originally drew, I'm going to measure all 3 angles of it. Notice that to measure an angle, I have to click on 3 points in order like I would name the angle. So angle B, C, A, if I want to measure this angle with vertex C. Measure angle. So this is angle A, angle B, angle C. This is an acute triangle because all 3 of those are less than 90. Okay? In an acute triangle, and I'm going to write this here. In an acute triangle, the circumcenter is inside the triangle. Okay? So let's see what happens when it's not an acute triangle. What if it's a right triangle? Let's see if I can make one of these angles 90. It's really close. Keep an eye on this angle right here. As I move it, the measurements change. I'm trying to make it exactly 90. It's going to be hard to get it exact. Ooh, I did it. Ta-da! Okay, now this is a right triangle. Well, where is the circumcenter? It's on the hypotenuse. Not only is it on the hypotenuse, it is right there where point, whatever that is, D is. Well, point D was at the midpoint, so it's at the midpoint of the hypotenuse. So I'm going to write that. In a right triangle, the circumcenter is at the midpoint of the hypotenuse. So it's on the hypotenuse at its midpoint. And finally, let me go back and get the arrow tool so I can move things around. I'm going to make it an obtuse triangle. How's this? That's an obtuse triangle because one of the angles is more than 90. And obtuse triangle, what I'm finding out in an obtuse triangle, the circumcenter is outside the triangle. Okay? So the perpendicular bisectors, again, meet at the circumcenter, and that circumcenter can be located either, let me get the arrow, inside the triangle, outside the triangle, or on the triangle if it's a right triangle. And I can move other points to see this. Inside the triangle, all those angles are acute. Outside the triangle, when one of them is 106, looking right here, or see if I can make it 90, getting close. There we go, on the triangle. Moving on, I'm going to go ahead and do the InCenter. So first I'm going to make a triangle. Now I'm going to draw my triangle and then go change the line weights. Click on all of those and go over here and say display line style. I want it to be medium. And I also want it to be solid. So there's my triangle. Okay. Let's go ahead this time and measure the angles right from the bat. Right off the bat, right from the start. Okay, so InCenter. To do the InCenter, I need to do angle bisectors. So to do an angle bisector, which you notice is right here, it's not highlighted right now because I need to tell it which angle do you want me to bisect. Well, to name an angle, I have to click on 3 letters. So let's click on BAC, which means angle A, and construct angle bisector. Then I'm going to do angle ABC, which basically means vertex B, angle bisector. And finally, angle BCA with vertex C, angle bisector. And look, they're concurrent, which is that special property we already knew, but it never hurts to remind ourselves. Let's go with dotted. That's a little better. I like that. Okay, so those are my 3 angle bisectors. By the way, I can, if I wanted to, I can confirm those properties. Like in other words, let's go back to the perpendicular bisector. Remember that we said the perpendicular bisectors meet at the circumcenter, and the circumcenter is supposed to be equidistant from the vertices. So let me measure the distance from G to each vertex. And as you would expect, they're all 7.5. If you look over here, or whatever they are, I can move this around and they're still always going to be the same because the circumcenter is always equidistant from the vertices. And the reason is it's the center of the circumscribed circle, that circle right there. Okay, let's go back over to angle bisectors and check what is the, let me first of all make that point, construct intersection. So D is the InCenter, and the InCenter is supposed to be equidistant from the what? Excuse me, from the sides. So I'm going to see if I can find out how far it is from each side. Sure enough, it's the same distance from each side. Now, as I'm moving this, let me point something out to you. Where is the InCenter? It's always inside, no matter what. When it's an obtuse triangle, when it's an acute triangle, when it's a right triangle, no matter what kind of triangle it is, the InCenter is always going to stay inside the triangle. Making it right, close enough that you can see it. Okay, so the InCenter of a triangle is always located inside the triangle. All right then, next, running out of time. This is a 15-minute video. We're at 11:49. So let's go. Let's construct another triangle. I'm going to go ahead and make all the lines solid. Okay, this time I'm going to do the medians, so I need to do midpoints. So I'm going to get the midpoint of each side, and I'm going to connect it to the opposite vertex every single time. And as we would expect, those segments are concurrent. Those are the medians. They meet at a point in the middle there that is called the what? That's the centroid. Okay? So what about the centroid? Does it matter whether I have an acute triangle or an obtuse triangle or a right triangle? Where's the centroid? And I'm not going to measure the angles because you can see this is an obtuse triangle. Let's make it look about right. No matter where I put it, no matter what kind of triangle I have, the centroid always stays inside, just like the InCenter. So the centroid of a triangle is always located inside the triangle, just like the InCenter. Okay, and finally, the altitudes. And I'm racing against the clock here. So for altitudes, I need to go through the point here and be perpendicular to there. That works. Through this point, perpendicular to this. These are my 3 altitudes. I'm going to make them dotted. If I get cut off, I'm down to like 1 minute, 15 seconds. You'll know. Dotted. Okay, so let's just look what happens before we run out of time. Oh no, it is going outside. These two, I'm going to say construct intersection. What is that point called where the altitudes meet? Uh-oh, I have something extra highlighted. Remember we said that was a problem. So D is called the orthocenter. And here it's inside the triangle. Here it's outside the triangle. Is it ever on the triangle? Yes. So here's how that works. The InCenter of an acute triangle is inside the triangle. The InCenter of an obtuse triangle is outside the triangle. And on a right one, it is located at the right angle. Let me go back here so you can see it, but I can't type it in time. There it is.